The Professor's Digital Dojo.
Good evening everyone and welcome back to the dojo. So in this short tutorial I'm going to go over displacement mapping, which is a really important concept in CGI imagery in which we use a texture to create geometry rather than modeling it. And the reason we do that is sometimes the textures are incredibly complex and it's easier to generate that geometry at render time than it is to create it or to try to model it out. So we're going to start simply, just kind of with an example, and we're going to do a polygon primitive plane. And let's scale it up to grid size here. So pull that up. That's fine right there. The other thing we want to make certain of, just to start, is that our geometry has enough resolution to start with. So I'm going to go with 50 times 50 here. So we're dealing with about 2,500 faces, and that's perfectly fine. That seems like a large amount, but for displacement, that's really still won't be adequate. We're gonna fix that here in a moment. However, we're gonna do something really simple, like I said to start, just to explain the way displacement mapping works. So, in displacement mapping, we use a grayscale map, and white values push upwards, black values push downwards, and gray values, of course, stay neutral. Now, to prepare ourselves for this, we do want to UV map whatever it is we're doing. And this, since this is a plane, we're going to do a simple planar map on this UV, and we're going to map along the y-axis. Pull this up here. And that just makes sure that whatever texture we put on is fitting within our boundaries and projecting properly. If you have more complex geometry, there are other things we'd have to do, but for now, let's just get the concept down pat so that we can understand what we're doing first. I'm going to assign an AI standard surface material, and within that shader group, if I bump over here, you'll notice that we do have a slot for displacement material. I'm going to make a light source real quick, and as usual I'm just going to use a simple sky dome light here in Arnold, turn it down to 0 for camera, and to viewport I'm going to turn its sky radius down to 0 just so that it's not visually in my way. Let's turn on our resolution gate so that we can see what's going on, and under our render settings let's make sure that we are set to full HD 1080 so that we've got at least a decent amount of screen res to look at here. Alright, so this will be the geometry that we're displacing, just a simple plane. Now to do the first one, I'm just going to do a procedural, meaning a texture built into Maya, a mathematical texture that we're going to use to displace this surface. A couple of things we have to do to prep this geometry to be displaced. The first thing is we need to come here under our shape node, come down to our Arnold tab. If it's not open, we'll just open our Arnold tab, roll it out, and then under subdivision, we're going to change our subdivision type from none, which is the default, to Catmull-Clark. It'll be abbreviated again as Cat-Clark. And I'm going to put the iterations just to start here at about 5. And what iterations mean is it's going to subdivide this plane that's already got 50 times 50 U and V divisions by 5. But that'll only happen at render time, so I'm not having to deal with this heavy geometry here in the viewport. I'll only have to see it when it comes time to render. So let's move over to our shader here real quick, and let's bump over to our shader group, and under displacement material let's hit our create file node, and we are going to just put a plain old checker on it. So the black areas should deflect downward and the white areas should deflect upwards in displacement. Now the scale is going to matter. We're going to start with 0.1, although that might be a little heavy. It'll definitely let us see if we have enough resolution on our plane and if the value that we're setting right here is good enough. There's one last thing though that I generally want you guys to do, and under displacement, for whatever we've set in here, if I have a color balance node, I need to make certain that alpha is luminous is checked, and then alpha offset needs to be set to negative 0.5. That'll ensure that the black areas deflect downward and the white areas deflect upward. If this alpha offset is left at 0, the black areas will not deflect downward. So it's an easy thing to forget, but it's something that we have to do every time as long as we have access to our color balance. And in fact, if I'm going to use a procedural and it doesn't have a color balance value, I generally won't use it because I really do need to set this alpha offset to -5, -0.5. So let's do, this was a different one I did. So here you can see the checker, the black and white checker, is pushing the black values down, the white values up. That's our displacement, easy peasy. Now let's go and let's adjust this a little bit. Let's go from 0.1 to 0.05. So we're making this a lot less powerful. And hopefully you'll be able to see now a little bit less displacement. There we go. And now hopefully let me set this so that we can actually see everything on screen. I know this can be frustrating for you guys. It's certainly frustrating for me to try to get it all in view here. It's so much easier when we're working on multiple monitors, isn't it? So just so you can kind of see this here at the same time that we're moving the camera around. Alright, that's what I want to do. Let's zoom in on this a little bit. And you can see now as I move it that that checker is displacing the geometry pretty accurately based on this division. Now let's change our displacement. I'm going to hit stop, minimize this. We're going to change our displacement from that checkerboard to something a bit more complex. So I'm simply going to right click on displacement material here, break the connection, and let's go and put in a different file node. This time we're going to use, let's say, a fractal, a solid fractal texture like so. Again, I need to put the scale. I'm going to start at 0.1, which again will probably be far too powerful. However, it'll allow us to at least see how this geometry is displacing based on the black and white of this displacement material. Now remember, there's a couple of things I need to do. Under color balance, I need to set alpha is luminance. It's already checked. And alpha offset needs to be set to -0.5. Now once I've done all of that, I'll hit render. And we can see the way this fractal material is now displacing this geometry. And like I said, I knew it would be a bit too much. So let's go in and, whoops, right here under scale, instead of 0.1, we're going to do 0.05. And you can see it's bringing that down. And we can continue to adjust this until we get to a value that seems to work for us. Now, that might be a bit subtle. Let's go to 0.03. And there you go. Now, I have, again, a sky dome light attached to this, so we're getting sort of a really unbiased 360-degree ping-pong ball type, sort of illumination here. So I'm actually going to go in and assign an HDRI, and that'll allow us to maybe see the contrast a little bit more easily. And I'll choose a random HDRI. I say random. I have a tendency to choose favorites when I'm doing demos, and again, under color balance, I want to make certain that alpha is luminance is checked for any HDRI image. Let's render this again. There you go. And now you can see how that fractal texture has really displaced the surface of our plane. Now this is pretty good. However, if I want to get a bit more resolution out of this plane, I do need to increase under the shape node and under our subdivision aspects here under the shape node. I might pull our Catmull-Clark subdivision iterations up to 7. Let's do a snapshot really quickly so we can see a before and after here. I'll pull this over. There you go. Let's render it again. And let's see if we get an increase in resolution and detail without my actually crashing. That's always sort of the coin toss here. When we start to put high iterations in our Catmull-Clark, Maya can start to run out of RAM pretty quickly. We should be okay here. Alright, there we go. And so Maya is rendering up. Not too bad. I'll actually turn on Arnold denoising just for this render so you guys can see it. So this was before at 5 iterations and now at 7. That's pretty rapidly diminishing returns. In other words, I think at 5 iterations we're getting about as much displacement as we really would need. But this is the point of displacement mapping, is I don't have to model in this very complex surface geometry. I simply need to make certain that my geometry has enough resolution, and then under my Arnold subdivision aspects under the shape node, that it has enough iterations under Catmull-Clark to create more resolution at render time to actually generate geometry based on a texture. Let's look at another case of use really quickly here. And for this one, instead of using a procedural texture like a checker or a fractal, we are going to go and use a file texture. So I'm going to right click on displacement material here, and let's break this connection. Let's open our create render node, and I'm going to go grab a file. Now for this, again, 0.1, I'm going to start there. I can use any grayscale image that I have, and I will go to my Maya textures here, and under folder I've got a lot of streets and things like that. Let's go and use this brick right here as our displacement map. As long as it's grayscale, it'll work. And under alpha offset, again, I need to set it to -0.5 to make certain that everything behaves the way it should. And let's take a look at this render using a file texture versus a procedural texture. So if I needed to create a brick or cobblestone or anything like that, as long as I have an image of it and it's been converted to grayscale, give Arnold a second to generate all of this tessellation here based on our Catmull-Clark iterations, and we should get a nice, whoa, way too displaced. So let's go over, and under scale again, I'm going to change that from 0.1 to 0.05, which might be too much. Give it a sec to catch up. Go to render, and let's update this full scene real quick. But hopefully you can see how this texture is literally generating all this new geometry that I did not have to model. Now, this is really important if I'm doing some very technical greebles or something like that, where I just want to add in a lot of sort of generalized surface texture onto a wall or something. Now this is still far too much displacement. So again, we're going to go and change this to 0.0.1. And this is a number that I'm going to play with. There is no magic formula for it. I wish there were, but we're getting closer. And let's let this render. I'll pause for a second and bring you guys back when we're done. Now we're starting to get a little closer. Hopefully you can see now how the bricks are displacing. That grayscale map of the bricks is displacing this geometry. And I think we can go to 0.00. Let's go 6. Whoops. And let's render that again, and I'll bring you back when it's done. So we're a little better here. And one of the things I could probably do to clean up this displacement is generally I'll take this image file that I'm using, Photoshop, and I'll probably blur it just a tiny bit to make sure that I'm not getting these, all of these really super sharp details, which we don't quite want. And in fact, if I change this to 0.02, that'll bring us down to a more rational displacement. This is especially valuable for shadow plates and things like that, where we need the shadow to look like it's moving across surface geometry as we're rendering it. And here we go. That's not too bad. It's a little sharp, and like I said, I would actually change the image file so that it behaved the way I want. Now let's look at maybe something a little more technical that'll work in a similar fashion. So what I'm going to do here is let's get rid of this plane and this placement node, and we're going to create a polygon primitive sphere. And again, we always do this out of a platonic solid, given at least 3 subdivisions to create a spherical join. However, because we're displacing it, I'm probably going to go all the way up to 6 here. And then under its shape node, again, I'll scroll down in my Arnold menu to the subdivision menu, and under the subdivision menu for type, none, the default, I'm going to switch to Catmull-Clark, and I'll give it at least 5 iterations. That should be enough for what we want to do here. Then, of course, I will give it a AI standard surface material, and I will UV map it. This is a sphere, so we will do a spherical UV map, which means I'm going to make sure that it wraps all the way around our sphere like so. Now, we have our standard surface material, and if I bump over, it pulls up our shader group, and I've got my displacement material slot right here, which I will click on this to pull up a create render node, and then I'll go grab a file. This is a greeble file. Greebles are something that were invented by an engineer at Industrial Light and Magic back in the 70s when they were still using physical models. And greebles are just bits of models that were added on to create surface detail that looked complex. In other words, if they were building a Star Destroyer for Star Wars, they would glue a bunch of race car model parts onto the outside randomly to make it look complex and technological. Here in the Maya, let's go to my displacement maps, and I have a good greeble map in here. This is it right here, sci-fi displacement. So once again, I've set my alpha offset to -0.5. We've set our scale to 0.1. Let's do 0.01. And we'll move on from there. And again, let's take a look at how our displacement is going to work. Normally we would see just a smooth sphere when we rendered this, but because the displacement map is designed to generate geometry at render time, we should see a pretty interesting surface coming to light here. And give it a second to render. And there you have it. So I've got my sphere that was originally just smooth. I haven't modeled any of this geometry. All of this geometry is driven, again, by the map, the grayscale map that I put on. We have all this beautiful technical greebling without me having to do one bit of modeling work. I'm simply letting the texture, the black and white texture material that I've applied to this sphere drive this surface geometry. Now, again, this is a super important concept to understand if you're going to do any sort of CGI modeling or animation or mixed media or cinematic work. I have to understand how to create super complex surface geometry without having to model it myself. Hopefully this is a good tutorial for you guys. If there are any questions, concerns, or comments, please leave them in the comment section. Otherwise, don't forget to like and subscribe. I hope you guys have a great evening. Thanks for stopping by in the dojo. Night, night.